Hey guys, welcome back to our channel Automation Bypass, and today we are going to continue on our series of process instrumentation. The topic for today's video is level measurement, and first of all, why we need to measure level. We measure level for the concerns of safety and process control. Now imagine a scenario you are controlling the liquid level inside a water tank that is providing water to the community, to the society, to the city. Okay, and you want to make sure that this level is within the upper and lower norm. So if it increase the upper level limit, it will overflow, which will make us look bad in front of the whole society. And if it goes down a process control low level, the sedimentation will come inside the pipe and will come inside the drinking water of the community. So this is one example of safety and process control. You can find multiple examples of such process control examples in various industries. For example, recipe making. You want to make a product, for example, ketchup. And for this process, you need to measure the raw ingredients level precisely to make the finished product. So on the right side, you can see what is the content of today's lecture. First, we will discuss the level gauges, and then we will discuss some technologies through which we can measure point levels and we can measure continuous level. So moving on, the simplest form of level observation is through a glass, through a direct observer. And these have three varieties that you can see in various industries. So first is the glass type, simple glass type. Okay. So we have a pressure vessel, a pressure tank, or some sort of liquid that you want to measure level of. On the side of this one is a sight glass attached with the ruler marking, with the level markings. And you can see how much the level rises inside this glass tube and measure accordingly the level. The problem with this form of level observation is that this glass gets dirty after some time of use. So to improve upon this one, we have a reflex type glass that allows you to see exactly the level at a particular time because it uses a reflex glass technology that reflects back the light at particular level of the liquid. If the level of liquid is above, so this light will get absorbed and you will be able to see clearly behind, and this will improve the observation. But still there have some chances of human error in this one. So to further improve this one, we have the magnetic type. So inside this one, you have a magnetic float and a magnetic ruler. So as this float is rising with the liquid, the ruler will change its orientation to show approximately good results of the level. So these are some different technologies that we use for level gauges. So for level measurement, you can use discrete control, digital control. For example, you want to know if the level is at a uh, particular height or is at a particular level. Okay, so for this one, you can use switches. These are level switches, and these are some of the various technologies that we use. First is the capacitive. So this uses the variance in its electric field as an indication of a level. You know that capacitor use dielectric, and if you employ capacitance inside a liquid, it will change the dielectric properties of the capacitor, and which will give you a signal that the level has reached at this particular sensor height, and this will give you signal. Okay, you can use this capacitive technology to measure liquids, and also you can use to measure solids, for example flour, for example some other grains. This is usable in both kind of substances. Another type you have optical. As you can see in the image, this uses the property of refractive index to tell you exactly what is the level. As the liquid level rises, so this will change the optical properties of the sensor, and this is detected by the internal circuitry of the sensor, and this will give the signal. So just along these lines, we have another one, continuity based level sensor. This measures the level with the varying resistance, and as the resistance is changed due to the rising of the liquid, This is detected by the circuit and this will give signal. Another one, which is also a common type, is the tuning fork based level switching. So they use vibrating tongues to measure the level of a liquid. So the level is detected by the change in frequency. Okay, and again we have a sensing circuit that will detect this and give signal appropriately. The most common type is the flow type level switches. They use these changes in their buoyancy. So construction wise, these are made lighter as compared to the liquid of which level they are measuring. So as you can see in the picture above, this is a very common type of float switch. So the material of this float switch is less dense as compared to the liquid level that it is measuring. As the liquid level rises, so will this sensor rise. And inside there is one metal ball. And depending on the orientation of this sensor, it will give a signal of on or off. Okay, it will use gravity and the concept of buoyancy for its use and give the signal of level switch. Another one, we have a magnetic type level switch. So again, the construction wise, its buoyancy is affected by the liquid level rising and falling, and this will trigger a magnetic circuit inside, and that will give the signal to our control circuit. So this is one of the common types that you can find everywhere in the process instrumentation world. For continuous level measurements, we have various technologies. The two technologies that I have decided to discuss is the ultrasonic level sensor and the DP level sensor. So ultrasonic sensors, they use a signal of sound and they detect how much time it is taken by the signal to propagate through the medium. The medium one is probably air or something else, and medium two is the liquid level that you are trying to measure. Okay, so as you can see in this picture, that the wave, ultrasonic wave, is emitted by the sensor. It goes down to the liquid level, it travels back, and is detected by the sensor. The time of flight for this signal is directly proportional, sorry, is inversely proportional to the level of liquid. If the level of liquid is higher, it will take less time for the sensor to detect. The time of flight will be less. And vice versa, if the level of liquid is lower, it will take more time to detect. And this one is scaled. These properties are scaled with one another. And by this technology, you can measure the level of liquid exactly. And on the right hand side, we have DP level transmitter, which uses the principles of fluid dynamics and differential pressure for their advantage. So again, we have two mediums. One is the liquid level, one is the level of the substance that you want to measure, and one is another medium, for example, air. So air have atmospheric pressure, and this liquid have its own pressure due to its weight. And using equations of Bernoulli and fluid dynamics, we can measure exactly what is the height of column of for this liquid or this substance, that level you want to measure. So based on the principle of differential transmitter, DP, differential pressure transmitter, you can also measure level. So that's about it for today, and we will continue this series very soon. Thank you guys for listening, and if you like the video, please share with your peers. Thank you.